Okay, I think I'm going live again. I need to stop doing this. So yeah, I've been running around here in Kalmar, beautiful Kalmar, trying to find the right spot to do this live session. And this is going to be a short one because I'm. What do you mean? I'm live, marketing department Peru. So please stop chatting in my ear. So this is. Hold on, I just need to delete this one. Okay, so sorry for that. Again, my name is Nicholas Byrne here at Winio, Digital Twin Specialist. I'm right now in Kalmar to talk about actually smart heating systems. And this will be because smart heating systems is something that, and as much as possible. And what we've done is that we've taken, or we actually, if we go back in time, I've been working with smart buildings for the last 7 years. And then 1.5 years ago, or almost 2 years ago, someone tipped me off that there is an innovation tender going on based in Växjö in Sweden. They want a self-learning, platform-independent, um, vendor, free, well, maybe not vendor-free, but platform-independent, self-learning, contextual smart heating system that is supposed to understand what is happening in the individual rooms of the schools that we're innovating with, in adherence to, well, the room, the building, what is going on in the city, to reduce CO2 footprint as much as possible. And because I've been working with this for such a long time, maybe this is something for me, because this was not supposed to exist yet, and it was, super innovative, really, really interesting. So we bid for it, we won it in competition with a couple of different companies, and we got started last year, in roughly around this time, actually, end of April, beginning of May. And it was really, really interesting because I have never done anything with smart heating systems in my entire life. I've never thought about it. And now, 1 year later, I love this so much. There's so much potential in making things more efficient, more effective when it comes to district heating systems. And basically how it started was that, this was during the pandemic. So we had to do everything remote. And of course, I've been working with digital twins for quite some time. And we took the drawings, turned them into 3D models, built up this 3D environment so we can collaborate, the energy expert, the technical asset managers, me as an innovation manager, the developers, and everything in between around the shared reality. And this was, extremely important because we couldn't visit this site really. And we had taken an open source software stack from California or for the US, Contiki wireless mesh, and then also a hardware solution, actuating solution from IMI here in Sweden, and I got amazing help. So basically, what we did was that the whole project was about connecting radiators. So very, very granularly to be able to control them again with an understanding of its context. So we took the sort of like the actuators from IMI with the software stack, created a whole new product with wireless mesh and with an edge native approach, which means that you preserve local control, cloud optional. This was supposed to be, again, self-learning and very, very independent. But I know that this takes time, so we got help from a really, really great player when it comes to smart heating space called Noda. So they've also been instrumental. They're also here with me in Kalmar with Johan, and taking this solution to create these smart heating systems that we're now 1 year in. But again, we need to go back a little bit in time. So doing this during the height of a pandemic in normal circumstances is not easy. Doing it during a pandemic is actually pretty hard. And we had to source components and everything, from all across the world. And we had, we got started at the beginning of May. And then we got it in the implementation for the first school, the small school, in beginning of August. And then we had the largest implementation in it was like a vacation time. So the importance of this was to get stuff in, and again to collaborate around the shared reality, not only for the smart heating systems, but also creating a new product, and also for the installers and everything in between. So we got everything done, and I'm fast forwarding along. I know a lot with the bumpy ride that we had, but we can now see that we've installed this in 2 schools, hundreds of sensors connected what is it? I think it's 83 radiators with actuators, so we can see what is happening in real time. And if I would hold my hand on top of a radiator, and then tell my developer to open up the valve or close the valve, I can feel the warm water, come into the radiator, and that's just an amazing experience. It sounds super nerdy, of course, but to be able to control stuff, over across the world in real time. So when I count down three, two, one, open or close, I can literally feel the difference, and that is really really important because everything has to be in real time. We got the importance also with the digital twin aspects is that you get this again shared reality, which is hard to explain right now because I don't have the 3D models in front of me. But if like the other important aspects that are being left out for the most part, or has been, I would say, is the user. How are they experiencing the building? So not just looking at it from a heating, ventilation, air conditioning perspective, and this part heating, but also the tenants. So if we go back to the 330-300 rule, that's been in the back of my mind when we architected the solution, that it of course has to counter or affect the energy side, but it also has to make life easier for the operations. So the technical asset management, and maintenance, predictive maintenance, prescriptive maintenance, and also to be able to cater to a dialogue, which is again the digital twin should be able to transform knowledge or cater to both people as well as systems. So the 330-300 rule, 300 is more aiming at the cost of personnel, well-being, productivity aspect, which of course has come really really into focus now during the pandemic, so that if in order to get buildings back, or sorry, like not buildings back, but people back to buildings, people need to understand what is going on and to be able to trust buildings. And again, if you have a 3D model that will tell you exactly what the temperature is, or the indoor air quality, or CO2, not just in a dashboard, but actually tell you that live in a in a way that a 7-year-old or a 105-year-old could understand. That's where I think we're going to get the impact necessary. So of course we know this is a layered product where we're using AI, machine learning. We're using digital twins, actuating, edge control. We're using taxonomies and ontologies, haystack, and catering to brick schema, and all this kind of nerdy stuff that is important. But again, what we're after is not only the 20-25% energy reduction and a complete transparency into the CO2 footprint in real time, because we also subscribe to the energy mix that is being produced by the energy producer. So there are multiple areas here which are extremely interesting. And for me, looking at it from a high level perspective, we can see that there's not a lot of transparency between the actors in the smart city or like a existing city ecosystem. So you have an energy producer, you have the schools, and you also have the citizens, right? And let's say the problem is that a lot of energy producers sometimes they can't necessarily see the forest because of all the trees. Because if they help out in making buildings more energy efficient, what happens? Well, they lose revenue, of course, because that means that the buildings don't necessarily need as much energy or water, heating, whatever that might mean, from the energy producer, which of course means that they lose business in the short run. However, if they also can, get more transparency, they can make their existing processes more efficient, which means that they can definitely save money and then also free up a lot of this kind of stuff. So that let's say that the city needs to build, or let's say that the city needs to cater to more citizens, and they see that they reach the maximum capacity of the energy supply. That means that okay, what are we going to do? Are we going to make things more efficient? Yes, of course, but not only not a lot of effort might go into these kind of things. It's like building a new power plant. But again, like if you have this what do you call it, the triangular aspects, what do you call it in link, not the trifecta, anyway, I digress. So if we have this again, like the citizens, well, the city, energy producers and the buildings in the city, you can get a really, really nice, virtuous cycle where you make existing buildings more efficient in the city, which of course leads to well-being, indoor productivity, better indoor air climate, of course, energy efficiency. You free up a lot of, power, so to say, for the energy producer. They're going to make their existing, ways of working more efficient, and they can also see what's going to come back to them from buildings in real time, which is going to make their life much, much easier in terms of prediction and, again, making things more efficient. But the cool thing here is also that it's going to affect the city. So when the city now says, okay, we got an influx of, people, or we want to build up the city, and they say, oh, great, we actually have, energy, that we didn't think that we have, or electricity or heating as a spare, now that, we've made things more efficient. And that is without building a new power plant. So you get, a really, really good virtuous cycle. But the problem, or the challenge, I would say, is that transparency is not always great for existing actors, unfortunately. Politics rule, people rule, of course. And again, like if someone out here, maybe I've read anything from Clayton Christensen, which is one of my, definite absolute favorite gurus. He says that, for disruptive innovation to take place, and I'm not really sure if this is disruptive innovation, but it's all about the business models. So again, if the energy producers could find another business model, which of course they could, if the ones that are servicing buildings, that they can do everything more remotely, right? If they, instead of having one person take 3 days in a building to, service it or to adjust things, they can actually have one person service 10 buildings in one day remotely and be predictive and offer completely new services on top of a digital layer. That would be really, really interesting. However, that's not necessarily how it works. So technology is great, but I also want to end this, live webinar with something that the user and the principal of one of these schools said, right? And that is, Nicholas, I don't care about the AI smart heating system, whatever that is. All I want is to get, great indoor air quality, a fantastic building, and, happy, teachers and happy students. If that is, through AI stuff or whatever that might mean, I don't really care. That's what I'm after. So looking at the KPIs or the key performance indicators or whatever the users of a building, hospital, school, data center, whatever that is, want, that is what we should leverage. And of course, we can't necessarily solve old problems in the same way or with the same tools that got us there. We need new mindsets, possible new business models, and definitely use new and modern technology in the right order to solve problems of the past. And again, like I think also what she said, which I think is profound, is that this way of working, utilizing a 3D model, of their reality, enables a dialogue and again communication, transformation, and knowledge transfer between otherwise siloed disciplines, because you're looking at their reality. So whether it's plumbing, whether it's HVAC, whether it's the actual teachers, the users, whatever that is, they can understand what we're doing. So I think there's a link to a video where we have gotten an MVP of this done to just explain, how the water is being transferred from, into the radiators, how it's going back, and a little bit, what we're doing. So we have CO2 sensors, we have temperature sensors, we have a lot of different things, but I gotta go now. But again, like it's not so much about technology in the sense of technology, but it's about the impact new and modern tools can, deliver much, much faster, better, and more transparent. And also, when you combine these technologies together, that's when you can get, fantastic, output, which I love. And thanks so much to Goda Hus, Goda Tech, which I'm here in Kalmar to speak about these smart heating system, and also of course to Vafab, which is the customer in Växjö, and to DXS, and to everyone that has been involved, that is continuing to be involved, and also Noda, of course. Thank you so much for listening. I hope this was, it is a rant, I'll give you that, but I hope it was more of an informative rant than anything else. Thank you so much, and have a great day. And if you have any questions regarding how to compete in the age of AI and deliver value almost like the 9% faster that we've done before, feel free to reach out, of course, with smart heating systems, but anything in between. Thank you so much and have a fantastic day. Bye bye bye.